स्टूडेंट्स, आज मैं आपको इलेक्ट्रिक एनर्जी एंड इलेक्ट्रिक पावर के बारे में बताऊंगा। तो फर्स्ट ऑफ ऑल, व्हाट इज वर्क? Work and energy are same things. When we do work, our energy is consumed. So we take many words from electricity. So first of all, we define the work. Now in general terms, the work is defined as the force multiplied by displacement. When you apply some force F and move an object to a distance d, then your work is called, multiply force F by d, you will get work, and its unit is joule. Now in terms of electricity, we have a test charge Q plus 1. This charge, every charge has its electrical field. So this is the electrical field around this charge. Now, what is potential? How can you define a potential? Let a point be A. Now, say potential at point point A is P1. So how we define it? From infinity, we take a unit positive charge to this point. The work done in taking a unit positive charge from infinity to the point A against the force of electrical field produced by unit positive charge Q plus 1. So here, when we take a unit positive charge from infinity to this point, say work done is defined as potential at point A, say P1. Similarly, at point B, the potential or work done from taking a unit positive charge from infinity to point B is, say, P2. Now, the difference of potential P2 minus P1 is known as voltage. What is voltage? P2 minus P1, potential difference, means for displacing a charge, unit positive charge from point A to point B, the work done is known as the potential difference, and we call this potential difference voltage. The voltage is called potential difference, and this is the voltage V. V is equal to P2 minus P1, and this V is the work done in taking a unit charge from point A to point B. Now, take a charge Q on the place of unit positive charge. Show now the work done, electrical work done will be V into Q. When we displace a charge Q from point A to point B, means voltage difference between which the voltage difference is V, then work done will be defined as the V into Q. let this equation be 1. Now you know what is Q. Q is the charge, and flow of charge is called current. The rate of flowing of charge is called current. Let there will be a conductor, wire. This cross section be, this will be its cross section. Here you take this, the cross section of the wire. Now per second, the flow of charge from this cross section per second. The rate of flow of charge is defined as the current. Here, I is equal to Q by T, where T is the time. Any coulomb per second is known as current, ampere. Now put the value of Q. You can write Q is equal to I into T. You put the value of Q here. So W work will be VIT. VIT joule. This is the electrical work, VIT joule. Now, further we define power. What is power? The rate of doing work is defined as power. कितनी तेजी से कोई काम करता है तो उसको शक्तिशाली कहा जाता है, पावरफुल कहा जाता है. Now power is equal to, power is defined as the rate of doing work. This is equation here, this is second equation. P is equal to W by T. Power, P is equal to W by T as per definition of power. Power is nothing but rate of doing work. कितनी तेजी से आदमी काम कर रहा है तो शक्तिशाली होगा. पावर, इलेक्ट्रिक पावर इज इक्वल टू इलेक्ट्रिकल वर्क और इलेक्ट्रिकल एनर्जी कंज्यूम्ड डिवाइडेड बाय टाइम. रेट ऑफ कंजम्पशन ऑफ इलेक्ट्रिसिटी. जैसे आप अपने घर में इलेक्ट्रिक यूज करते हैं तो मीटर कितनी तेज चलता है, जितने सारे सामान, सारे इलेक्ट्रिक अप्लायंसेस यूज करते हैं तो मीटर की स्पीड उसी हिसाब से तेज हो जाती है. Power P is equal to WIT. You put the value of W from equation 1. You will get VIT divided by T is equal to VI. This is here W, joule, time, second, joule per second. It is joule per second. This unit is taken as the unit of mechanical work. Now in electricity we say watt, W-A-T-T, watt. So मैं इसको मिटा दे रहा हूं. Now we find the first formula of electric power. P is equal to V into I. Electric power P is equal to voltage V and multiplied by current I. This is the first formula of electric power, or rate of consumption of electric energy. Same thing. Now you take it equation A. Now using Ohm's law, two different forms of this equation can also be written. Ohm's law, V is equal to IR. Now put the value of V here. So P is equal to I square R. This is second form of, let B, equation B. This is the second form of power, electric power equation. Now, third form, put the value of I from Ohm's law. I is equal to V by R in this formula. So, P is equal to I. At the place of I, you write V by R. You get V square by R. This is the third representation, C, equation C. A, B, C. These are three forms of electric power, and this is very important when you solve the different type of questions. Now, I will take some numerical examples of related to these formulas. When you lit a 40-watt bulb in your house, you get the voltage 220 volt. So what will be the current drawn by the bulb? Now, this is the bulb. You connect it from your mains household supply. P is equal to 40 watt. 40 watt बल्ब है और आपकी वोल्टेज 220 वोल्ट is given to this bulb. Find the current. Now, you use here this formula. V is given, P is given. P is equal to V by VI watt. Here P is equal to 40, V is equal to 220, I is equal to I. Then you can find out I is equal to 40 by 220. When you solve it, 0 vanished, 2 by 11. When you divide 2 by 11, you will get 0.0 one time 11. This is 9. 98 times 88. 2. Again, same thing will be repeated. 1818. Say I is equal to 0.18 ampere. This is your answer. This is very simple to solve. Now the next question, some tricky question. Second question. एक इलेक्ट्रिक बल्ब है, उस पर रेटिंग लिखी हुई है, यू यूज इन योर हाउस, दिस इज द बल्ब, रेटिंग है 220 वोल्ट, 100 watt. Generally you use it in your house when the voltage is 220 volt. Now an electric bulb is rated to 20 volt and 100 watt. When it is operated on 110 volt, the power consumed will be. अगर ये बल्ब 220 वोल्ट के बजाय 110 वोल्ट की सप्लाई से जोड़ा जाता है तो पावर कंजम्पशन क्या होगा? Here in normal case P is equal to P, this is 100, power is 100, V is square, VI. Now here we have written three formulas, P is equal to VI, P is equal to V square by R, and P is equal to I square R. Now here he says that what will be the power consumption. अगर इसको आप 220 वोल्ट पर यूज करते हैं तो 100 वाट पावर लेता है. अगर आप इसको 110, if you use it this bulb at 110 volt, then what will be the power? Two circuits. 220, then here P is equal to 100 watt. Now second circuit, hundred 10 volt, P is equal to what? Now you use the formula. Here we see that resistance of the bulb is constant. So we use the formula P is equal to V square by R. In this case, when we use on 220 volt, this power is rated 100 watt. And what will be the power consumed here? So P1 is equal to V1 square by R. R is constant for a bulb. R1 बराबर R2 for a given bulb. Same bulb है तो उसके लिए number 1. Now similarly here P2 is equal to V2 square by R2 square. Now from equation 1 and 2 you can write P2 by P1 is equal to V2 square by R2 R1 सेम है तो R ले रहा हूँ. You take R, V2 square by V1 square by R square. So you get V2 square by V1 square. Now put the value of V2 रेटिंग लिखी हुई है, घर में यूज करने के लिए बल्ब बनाया गया है 220 वोल्ट पर. When it is used at 220 volt, its power is 100 watt. What will be the power when it will be used at 110 volt? So what power will it give? V2 square. So V2 110 square by 220 square. So from this, P2 is equal to P1 multiplied by 110 by 220 k whole square means 1 by 2 k whole square. 100 watts multiplied by 1 by 4. This will come 25 watt. When a bulb of 100 watt, which is made for use at 220 volt, when it is used at 110 volt, it will consume the power 25 watt. Means its brightness will be 1/4. मैं मिटा दे रहा हूं इसे. Let it be removed. Now I will tell you the commercial unit of electricity, how the consumption of electricity is recorded by the meters, and how the international unit of the electric consumption is recorded. Unit of electric consumption. Watt is a very small unit of electricity. So in trading, we cannot use the watt, so we use kilowatt. Kilo means 1000. So we use kilowatt. Say kilowatt. Kilowatt, 1000 watt. Kilo means 1000. Now, if we use appliances of 1 kilowatt for 1 hour, then we say that 1 unit, commercial name of electric consumption is known as unit. So 1 unit of electricity is consumed. So 1 kilowatt. 1 kilowatt is used for 1 hour. This is 1 kWh. So kWh is the electric unit of electric consumption. Now, you take some numerical question, it will be very clear how many units you have consumed. Say you use an AC of 2 kilowatt, or say 2000 watt for 8 hours. Per day. For 8 hours per day. So consumption of electricity for 1 month, How will you calculate? Unit kWh is equal to 2 kilowatt, 2 kilowatt, 8 hours H multiplied by 8 hours. And if you take it for 1 month, say 30 days, 30 days. So how much unit will you consume? You multiply 480 units. And generally, you are charged at the rate of 8 unit, 8 rupees per unit. In general, approximately 8 rupees per unit is charged from the supplier. So you have to pay in 1 month rupees 480 units multiplied by rupees 8. This will come approximately rupees 3,840 approximately. You will pay for 1 month. Okay, students, you have to practice the numerical problems, but you make clear your basics. And by you will find that things are going to be very easy. And for your remembrance, we have already told you that first time you will study the topic, then you revise it between 1 week and 2 weeks. First time. Second time, if you revise it between 30 days and 45 days, then this will be printed permanently in your mind. Thank you for today's lesson. Thank you very much.